Hello everybody, welcome back to Math 1351, more on math. Today we're going to talk about Chapter 10, Section 2. Section 2 deals with displaying data, Part 1, because you'll see why in a second. It's Part 1 and Part 2. The objectives of this section: we're going to discuss categorical, numerical, and ordinal data. We're going to look at dot plots, stem and leaf plots, histogram and bar graphs, and circle graphs. Once collected, the organization and visual illustration of the data is very important. As I say, a picture is worth 1,000 words. And that's what I'm saying, is we're going to take our data and make it look like a picture, so when you look at the picture you can interpret what the data is saying. Now, the reason it's Part 1 and Part 2, because here we have different types of visual illustration techniques we're going to be discussing in this chapter. Pictographs, circle graphs, also called pie charts, dot plots, also called line plots, scatter plots, stem and leaf plots, box plots, also called box and whisker plots. We're going to look at frequency tables, histograms, bar graphs, and frequency polygons, which are line graphs. All right. So those are all the ones we're going to talk about, and we're going to learn how to do those as well. So, the first question: what is a graph? A graph is simply a picture that displays the data. It tells us a story. What we have, how many we have, how are they grouped. So now here we have the word data. Okay, now first let me just distinguish data versus information. Data is the responses, the solutions, the answers we get to our surveys. Once we collect all these numbers, that's data. Once we process it and make it into something, then it becomes information. So data is simply the raw numbers that we get. The responses. We have three types of data. We have categorical. This is data that represents characteristics of objects or individuals in a group. Okay. They go into categories. That's why it's called categorical. The next one is numerical. Numerical is data collected on numerical variables. For example, distance an object jumps. Stock market progress. A person's weight. Not this time of year. Alright, and the last type is called Ordinal Data. Ordinal data is a combination of numerical and categorical. Data. For example, a Likert scale. The Likert scale is the one that has from 1 to 5. Very good, good, no opinion, bad, very bad. That's a Likert scale. So we take your opinions on varying scales and we numerate it. We quantify it to a certain specific numbers. These are questions that actually have mathematical meaning. More than a yes or no question. This one has since it's varying from very good to very bad, and also it doesn't matter how you do this. A lot of people have the smaller numbers very bad to the highest numbers very good. So I had this one backwards. All right. So those are the three types of data that we can have. Let's look at the first type. Pictographs. A pictograph uses a picture or icon is used to represent a quantity of items. Okay, I'll show you an example of this in a second. You have to have a legend. A legend that tells us about what the symbols represent. It's used to show us comparisons of quantities among different categories. A limitation how much does a part of a picture or icon represent? When you see the example, you know what I'm talking about. Here's some examples. For example, here's our frequency data. Number of students in each teacher's 5th grade at Hillview School. Teacher Ames has 20 students. Ball has 20 students. Cox has 15. Day has 25. Eves has 15. Fagan has 10. Now, a pictograph we could represent like this way. Each one of these student representations represents 5 students. So since we had 20 students here, that's 5, 10, 15, 20. 5, 10, 15, 20, 5, 10, 15, 5, 10, 15, 20, 25, 15, 5, 10. So that's how a picture graph is used. All right. Here's another example. This is what I talked about earlier. What about half a picture? What does that mean? Well, in the legend down here, each animal equals 2 votes, and each half animal equals 1 vote. So the student's favorite dog, Beagle. We had 2, 4, 6 students who liked beagles. Collies, 2, 4, 6, 8, 10. So each doggy is 2 votes. German Shepherd, 2, 4, and a half, so it's 5. This one has 5. Poodle has 2. Dalmatian has 4. So clearly, the most dogs represents the most favorite is a collie. All right, so this is what's also called a frequency count table, because we have the frequency of each of these. So it's 2, 4, 6, 2, 4, 6, 8, 10, 5, 2, 4. All right, so that's that. A picture graph must have, these are the must-haves, a title. Again, you have to know what you're looking at. Here's a title. Student distribution. Student's favorite dog. So it has to have a title, so you know what you're looking at. Source of the data. From Hillview School. Another one is from students in the classroom. Key to a pictograph, or an icon. This is the legend. Each person represents 5 students. Each dog represents 2 votes. Each half dog represents 1 vote. So you have to know what you're dealing with when you look at this picture. And uniform size of symbols. Each of these symbols all have to be the same size. All of them have to be the same size. So it makes it easier to compare each of the groups, the categories. Alright, so that's about pictographs. The next one we're going to talk about dot plots. Or line plots. Dot plots are a quick and simple way to organize data. Organize data. Used when you only have one group. Of data. And the size is less than 50. You don't want it too big because then it gets too clumpered. A line plot uses a number line as its base. So here we have a number line. One, 2, 3, 4, 5, 6. So when you look at your data, and if your chart has, okay, here's the item, and this is the count. So 0, we have 2, 1, we have 1, 2, we have 3, 4, we have 6, 5, we have 0, and 6, we have 1. So here's your data. What you do here is you put X's. Since there's 2 zeros, we only have 1 1. We have 3 2s. 3 3. So I put 3 3. 4 has 6. 1 2 3 4 5 6. 5 has none. 6 has 1. So that's, you just convert your frequency chart. This is a frequency chart. Each item and how many they have. That's the count of it. So you simply put it that way. A cluster is a group of points. So we see a big cluster here. And a gap is a large space. We see a gap here. When you hear the word mode, like in fashion, the mode du jour, it's what everybody's wearing. It's the most frequently worn object. So the mode in this case is the most frequently occurring. That's what the mode is. So that's a dot plot. All right, the next one. Next one is called a stem and leaf plot. In stem and leaf plots, the scale is vertical. Digits are used instead of X's. So for example, here's our data. 42, 51, 46, 57, 72, 65, 61, 67, 43, 66. Let's say that's our data. So our stem and leaf plot looks like this. This is our stem. This is our leaf. Our leaves. The stem part represents the tens digit. This part represents the ones. So your steps. Find the high and low values. Decide on the stems you're going to use. List from least on top to greatest on the bottom. Create the leaves. The leaves. Ordered from least to greatest. This is, how do you call that? Sorting. Then you add your legend. And then list your title and description. So these are the 7 steps. So here we have our data. Our highest number is 72. Our lowest number is 42. So that's from 47. So our stems are going to be 4, 5, 6, 7. So 40s, 50s, 60s, and 70s. That's what I did. I listed my stems from top to bottom, least to greatest. Now create the leaves. Now this is where it becomes complicated because I have to look at all the 4s. Here's a 4 here, 4 here, and a 4 here. When you put the leaves in there, start with the smallest. 2, 3, 6. So 2, 3, 6. Okay, there are no more 4s. Okay, then the 5s. We have 51, 57. So it's 1 and 7. So this is 51, 57, 42, 43, 46. 6 has 4 of them. We have 1, 5, 6, and 7. So it's 1, 5, 6, and 7. 61, 65, 66. And then 72. So I ordered from least to greatest, going from left to right. Now my legend. So number on the left is the 10s, number on the right is the 1s. That's the legend. In the title, I say average grades on a Calculus 3 exam given to first graders. No. Alright, so that's a stem and leaf. This is with only one group. If you have 2 groups of data to compare, then use the back to back stem and leaf plot. That's the next one. Back to back. Stem and leaf plot. Used to compare two groups. Okay, so here's data from group 1. We had 42, 51, 46, 57, 72, 65, 61, 67, 43, 43, 66. And data 2. 59, 51, 40, 63, 75, 79, 70, 53, 4, 5, 6, 7, 8, 6, 7, 8, 9, 10. So I need some more. 60, 60. Alright, now since we have two different groups, and they're all two-digit numbers, so the back-to-back stem leaf, here's our stem, leaf 1, leaf 2. Again, like I did last time, the highest number of all of the data is 75 or 79, and the lowest is 40. So 40, 50, 60, 70. Now, leaf 1, I look for 40s. I have 42, 46, 43. So it's 2, 3, 6. 50s, I have only 2, 51 and 57. 60s, I have 61, 65, 66, and 67, and 72. That's group 1. Now, data on group 2 goes the other side. How many 40s? Okay, 40, that's just a 0. How many 50s? I have 51, 59, 53. So it's 1, 3, 9. 60s, I have 0, 0, 3. I have 70, 75, 79. Notice it always goes from the stem small to large. Small to large. So there's my stem and leaf, my legend. So here's the stem. It's inside the box. Whatever's to the right is the one. So it looks like this. That's for this side. On this side, we have to know that the number to the left of it is the ones. So there's our legend. Then we have a name, description, all sort of stuff. All right, so that's a back-to-back, because the backs are facing the stems. Right? I'll use the same data as last time. The next one we talk about are called grouped frequency tables. So, looking at our stem and leaf plot, let's look at all the data here for both leaf 1 and leaf 2. We know our grouped, well, we go from the stem and leaf back to back, stem and leaf plot. We can group values in ranges of 10 units. We can go, okay, here I'll put it over here. There's a stem and leaf. So 40 we had 2, 3, 6, 0, 9, 3, 1 is 5s, 3, 0, 0 are the 6s, 9, 5, 0, and 2. Right. So this data here and our frequency. Okay, actually before we do a frequency, we have something called the tally. The tally is here. So we have a group. This goes from 40 to 49. We have 1, 2, 3, 4. So it's 4. That's the frequency. And the numbers 50 through 59, that's this range. We have 1, 2, 3, 4, 5. And then from 60 to 69, we have 1, 2, 3, 4, 5, 6, 7. And then from 70 to 79, 1, 2, 3, 4. So there you have your grouped frequency table. And the range, these are the ranges from 70 to 79 to 60 to 69, so groups of 10. If you ever take a statistics class, actually we're going to learn this later on, and when we talk about statistics, this can be very important, because from here we can figure out, we know what the mode is. It's the highest frequency. It's the most commonly used, so it's in the range of 60 to 69. That's called the modal group. Right, so that's group frequency tables. The next one we're going to talk about histograms and bar graphs. Histograms. They're adjoining rectangles or bars from stem and leaf plot. So what this is, the stem and leaf plot are the actual numbers. The histogram will be the bars representing it. The horizontal scale, or the x-axis, represents the stem. The vertical scale, the y-axis, the number of each leaf. It's a count. To 59, 60 to 69, 70 to 79. So we have in this one, we have 1, 2, 3, 4, 5, 6, 7, 8. So this is my group. This is the frequency. So in the 40 to 49, we have 4 of them. We have 4. In 50 to 59, we have 5 of them. In 60 to 69, we have 7 of them. And 70 to 71, we have 4. So sometimes in histograms you'll have numbers 4, 5, 7, 4 written on top, so it makes it easier to see. So you have to keep on trying to graph it back. You notice histograms, they're touching. A bar chart, a bar graph, would be similar to the histogram. We have the 40 to the 50, and the 60, and 70. So this is the group 40 to 49, 50 to 59, 60 to 69, 70 to 79. 1, 2, 3, 4, 5, 6, 7, 8. Remember, this is our groups, and this is the frequency. So for the first one, we had 4. The next one, we had 5. The next one, we had 7. And the last one, we had 4. Notice that there's a gap. Bar graphs have gaps, or spaces between them. The limitation of the histogram. I'll put it on the next page. So that's the example of the 2. You cannot retrieve the original data as you can from a stem and leaf plot, because all it does is represent the frequency of them, so the data is gone. The height estimation may be needed depending on the vertical scale. I had 1, 2, 3, 4, 5, 6, 7. What if I had 2, 4, 6, 8, 10? Here, and the 40 to 49, I knew I had to go up 4 units. And this one here also. But the next one, the 50 to 59, that one's pretty easy. I just go up 1 here. But in this next one, I had to guesstimate where it is. So that's a limitation with that. Bar graphs have spaces between each bar. They're used to depict categorical or ordinal data. No ordering is needed. You just do it. So a bar and stem graph, you do have to put it in special order. You have to put it increasing lowest to highest on the outsides. All right, let's look at some examples here. Here's what we have from our survey. Favorite drinks. Punch had 12 votes. Water, again, here you have the estimation. So it's halfway, so we're saying it has 2 votes. Juice, 20 votes. Milk is 12. How many more votes did the punch get than water? Well, we know punch got 12 votes. Water had 2 votes. So 12 minus 2, 10. Punch got 10 more votes. How many fewer votes did milk get than juice and water? Milk got 12 votes. Juice got 20. Water got 2. Now, what this thing says, milk got, but juice and water. So together, they had 22. So 22 minus 12, it says fewer. So milk got 10 fewer votes than juice and water. How many more votes did juice get than punch and water? Juice equaled 20 votes. Punch was 12 votes. Water was 2 votes. So together they're 14. So 20 minus 14 is 6. So you got 6 more votes. What is the difference between the number of votes for juice and the number of votes for water and milk combined? The difference between is minus. The number of votes for juice is 20, and the number of votes for water, which is 2, and milk, which is 12 combined. So that equals 12 plus 2 is 14. The difference is 20 minus 14 is 6. The difference. So that's how we use a bar graph. We can also have a double bar graph. Double bar graph is used to make comparisons between two groups of data. Use our back-to-back stem and leaf plot data. So we had leaf 2, stem, leaf 1. Two, 3, 6, 0, 1, 7, 9, 3, 1, 3, 0, 0, 1, 5, 6, 7. Alright, so from the stem and leaf plot, this is our ranges. So in the 40 range, the first group group 1 had 3. And the second group had 1. In the second group, group 1 had 2, and the other group had 3. Notice group 2 so the shaded part is group 2. In the third one, group 1 had 4 and group 2 had 3. Group in 7 only had 1 and the other one had 3. So that's how we use side to side. Remember, they're bar graphs, so there has to be a space. Between each of our sets, because it's a bar graph. So you can compare the values next to each other. Misuses of bar graphs. Misuse of bar graph. 1. Omitting the scale. In other words, if I didn't have the frequency right here, you could tell one's bigger, but you can't tell how much bigger. But once you have the scale, you can compare, see exactly how big the comparisons are. A line break in the vertical axis. So if you have a line break between your numbers, or in your number data set, you have 1, 2, 3, 4. So the immensity, the difference, actual difference of the two is less pronounced if you have a line break. Does the graph start at 0? So if it doesn't start at 0, it's the same difference as what happens in the one above. The numbers on the vertical axis are equally spaced. Like right here, 1, 2, 3. Why are they equally spaced as opposed to 1, 2, 3? So these are all things you have to look out for. Other bar graphs. A percentage bar graph. A stacked bar graph. 2, 3, 4. $20, $30, $40, $50. So we have one object, let's say, has 4%. Has 14%. This is 4%, 14%, 24%, 10%. Let me get another pen here. All right, so there you have a percent bar chart. And remember, the importance of having the percentages written on top of it. A stacked bar chart let's look at this one. One is only 4%. The next one's 14%. The next one's 24. And the last one's 10. So it's relative proportionally to the entire graph that goes up and down. Here's an example of what I'm talking about. There are a couple of them, actually. You did the frequency, you figure out the percentages. And from there you can create a stacked bar chart. Now, how do we go from the frequency to the percentages? First step. Count or tally all the frequencies. That gives you an n value, the total number. So we have 7 plus 3 is 10, plus 14 is 24, 25, 29. So in this case, it equals 29. Divide each frequency by n. In this case, it's 29. So we have dress, flip-flops, Crocs, loafers, tennis. The frequency is 29. So we had 1, 4, 7, dress, flip-flop. Oops, dress is 1. This is the frequencies. So it's 1 for dress, 4 for flip-flops, 7 for Crocs, 3 for loafers, 14 for tennis. We take each one of these divided by 29. Check that out. So we have 1 divided by 29 equals 0.034. Multiply by 100. So you get 3.448. It's approximately 4%. Next one is 4 divided by 29 equals 1.1379 times 100. Get 13.79. That's approximately 14%. 7 divided by 29 is 2413 times 100. So it's 24.13, approximately 24%, round down. The next one, 3 divided by 29, 1034 times 100 is 10.34, round down 10%. And likewise, 14 divided by 29 equals 0.4827 times 100, or move the decimal 2 places to the right, 4827. So when you add all the percentages plus 4, we should come up with 100%. And that's how we stack up these things accordingly. So this is approximately 48%. That's approximately 10%. Twice that much, 14%, and a very small amount is 40%. And you can also have a stacked bar graph. Again, find out the same way. Add up each of these, get your n values. Divide by them, find the frequency. And materials is the bottom one. The percentage of this one for that list is approximately 34%. The next one also approximately 35%, and so on and so forth. And just put one on top of the other. Okay, so those are the bar and stacked bar. The last one we're going to talk about is the circle graph, or the commonly called pie chart. This one is where you partition a circle into sectors or sections. With each sector shown as a percentage of the scale of the whole. So partition a circle into sectors, with each sector shown as a percentage of the whole. So you have your range, your x values. You have your frequency Let's look at this. Let's look at the data. Under 5, 5 to 9, 10 to 14, 15 to 19, 20 to 24, 25 to 64, and over 65. Okay, so this one here, I didn't get this. I didn't get the data, the frequency. So approximate percent. Remember, it's the frequency divided by the total times 100. .8%, 6.7%, 7.2%, 7.1%, 7.1%, 52.7%, and 12.4%. If you add those up, you get 100%. That's the first thing. Go from frequency, add them all up, get your n, and each frequency divided by n, whatever that is, times 100, you get a percent. Now take the approximate percent times it by 360, because you want the percent of a circle, which is 360 degrees. We get approximately 24 degrees, 24 degrees, 26 degrees, 26 degrees, and 189 degrees, 45 degrees, whoops, 24, 24, 26, 26, oh, there's another 26, 189, and 45. Add them all up, you should get 360 degrees. Now, let me show you what I mean by that. So we have 6.8%. We have to convert that into decimals first, which is 0.068. So 0.068 times 360 equals 24.48. So approximate it 24 degrees. 6.7% is 0.067. Now let's move it 2 to the left. We want the decimal version of it. 0.067 times 360 is 24.12, so it's approximately 24%. 7.2, so it's 0.072. So 0.072 times 360 equals 25.9, which is approximately 26. 0.071 times 360, 25.56, so it's approximately 26. Same with that one, 26. 52.7 is 0.527, so 0.527 times 360 equals 189.72. It'll be 190. And then 0.124. When you convert from percent to decimal, move it 2 to the left. So it's 0.124 times 360. 40.46 is 45. So again, it's approximation, because when you add them up, you want to be 360. So what you do there, start with the center, and find 24 degrees. So pick a line. So you could pick that line. So 24 degrees from that is, say, about there. So that's 6.8% of the circle. And another one the same size is 6.7%. So this is the first group. This is the second group. The third group is 26, just a little bit bigger. That's 7.2%. That's 26 degrees. So this is 24 degrees, 24 degrees. Get your compass from there, 26 degrees, and so on and so forth. From this line, measure out another 26 degrees, 7.1%. And then another 26%, which would be 7.1%. And from there, from this line here, you want 189 degrees. So there's 180, so 189 degrees is approximately there. So this is 52.7%. And what you should have left is 12.4%, which is 45 degrees. So that's, or you can use Excel. Plot the points. You have group 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6, 7. Enter the percent. 6.8%, 6.7%, 7.2%, so on and so forth. And highlight all that and have the graph drawn for you by Excel. Alright, here's the last example. Here you have information is based on the survival and death rates from the Titanic. A. Construct a circle graph or pie chart of the survival group. Construct a stacked bar chart of survival and death group. Use stacked bar graph of survival and death group and compare them. Again, so we have this data. What you do first is take each of the data for the survival. You have 220 divided by 710, you get that. Convert that to decimals, multiply by 360, you get this. 118 divided by 710, multiply by 100 here, or take the decimal, multiply by 360, you get that, and so on and so forth, and converts to this. Excel will also convert those into stacked bars. So what can we conclude is the survival of first class and crew and third class. So people who didn't fare too well overall were the second class. The death rate, most of the crew died, then third class, second, and first class lost fewer people overall. All right, so good luck in your homework, and we'll do part 2 in a second.